Hello everyone, welcome back to the channel. This is Jose from MyCareerPS.io, and in this video we're going to learn to build a REST API using Flask. We're going to build a very simple API, a to-do API, an API that allows us to create tasks. We will be able to list those tasks, we will be able to get the details of a specific task, we will be able to update it and delete a task as well. It is a very simple API, but it contains nearly everything you need to build more powerful APIs in the future. Now, Flask is one of the most popular Python web development frameworks. I've got a lot of requests to create more videos using Flask, and so this is the first of a series of videos that I'm going to be creating about Flask. And this year also I plan to create a full course about API development with Flask. So this is just the first in a series of videos on this topic. Now, for those of you who are not familiar with it, Flask is a very popular Python framework. One of the reasons it is so popular is because it is very minimalist framework. It is highly non-opinionated, and it gives you a lot of flexibility and of choice on how to structure and configure your applications. What this means is that you can get a web server up and running with just a few lines of code, but it also means that there is a lot of burden on you to do things right, to choose the right technologies, to do things like templating or using the right ORM to interface with your database, and also on how to structure and model your application. With great flexibility comes great responsibility, so you have to make those choices right. And this is what I see a lot of problems happening in many Flask applications. Sometimes the structure isn't right, the way we bring things together isn't quite working very well, the choice of libraries isn't very good. And this is especially true for APIs. So I've worked with many companies that use Flask applications, and then they decide to build APIs on top of them, and that's where things go astray often. So sometimes they don't even use proper libraries to build those APIs. They use they do a lot of data validation on their own. They create their own custom data validation models. They handle URL query and path parameters on their own. And basically, they are reinventing API frameworks by doing it that way. So what I want to do in this video is I want to help you prevent those problems by showing you how to build an API using a robust API library for Flask and how to handle all those common cases properly. Now, like I said before, Flask is non-opinionated, it is very minimalist, it is very light, and so there's usually a great variety of choices on how to do things in Flask, a great variety of libraries that do the same thing, and you have to be able to choose the right library for your job. And this is especially true for APIs. There's a great variety of API libraries for Flask, and it's often not easy to decide which one is the right for your job. So what we are looking at an API library is something that gives us very robust data validation functionality, something that can handle URL query and path parameters out of the box, and ideally something, because we're building REST APIs, so something that has an understanding of REST APIs, how REST APIs work, an understanding of JSON schema semantics. This is not easy. It doesn't come like this in many API libraries in Flask. Ideally also something that can generate documentation. So if you are familiar with Fast API, you know Fast API can generate documentation from your code. So we would want something like that in Flask as well. And I'm not a big fan of the idea of building the API first and then getting the documentation out of the implementation. But in my experience, I prefer the approach of designing the API first and then implementing according to it. That's a different story. But my experience is frameworks that generate documentation have a better understanding of how OpenAPI works, and then hence they usually have better support for building robust APIs. So we want a framework that has that kind of robust understanding of how OpenAPI works. So in my experience, one of the best frameworks for that is Flask-smorest. So this is a plugin for Flask. It is built on top of Flask, and it uses a library called Marshmallow to perform data validation. And so if you are familiar with Pydantic today, Pydantic does data validation and parsing. Marshmallow does the same, and it's kind of the precedent of Pydantic. It was the classic before Pydantic came along, the one library we all of us used before Pydantic came along. And so it is a very robust, very battle-tested library. So it's a good thing that Flask-smorest works with that library. If you want to learn more about Flask-smorest, I'm going to leave details of the library in the description of the video. All the links that I'm showing you here, including the link to the Flask-smorest documentation. I also highly encourage you to take a look at the Marshmallow GitHub and documentation to get familiar with how Marshmallow works. So that's what we're going to do. We're going to work with these technologies to build a REST API using Flask. I'm going to show you how to do that from scratch. And without any further ado, let's get on to it. So the first thing we're going to do is we're going to create the folder for our application. So we're going to say make directory Flask todo API. We're going to cd into this folder. And now we have to set up the environment. I'm going to use Poetry for that. I've used Pycharm in previous videos, and I've got a lot of requests to start doing things with Poetry since it's so popular and so widely used today. So we're going to use Poetry here. So to set up an environment with Poetry, we're going to do Poetry init. This initializes the environment. It's going to ask us some questions about how we want to set up the application. We're not going to spend a lot of time here. The package name is fine like this. Version is fine. We don't need description. It's just a simple tutorial. The author name, maybe this is microapis.io Jose. License is fine. Python version, we're going to use 3.10 here. And dependencies, I don't want to generate them interactively. And also development dependencies, we want to leave that empty. So we want to generate this file like this. What Poetry creates is a pipeproject.toml file. Has a very simple description here based on the questions we answered. What we're going to do now is we're going to install the dependencies as a separate step now. So we're going to say Poetry add Flask and Flask-smorest. Now Flask-smorest itself is sufficient, probably it comes already with Flask, but specifying Flask would allow us in some situations to pin the specific version of Flask we want to use. So with that done, now we have to activate the environment, and we're going to say Poetry shell. That's the environment activated, dependencies installed, environment configured, we are ready to get going, and we are going to start coding the application. We're going to put everything within a single file. Like I said before, Flask is non-opinionated, very light, gives us a lot of choice on how to do things, so you can implement a whole application in a single file if you wanted to. Don't recommend that in proper projects, in big projects, but for this it's a very simple application for illustration purposes. Everything fits in a file, so just for convenience we're going to do it that way. So we're going to say touch app.py, that's our file. Now what we're going to do is, with our favorite code editor, we're going to open the project. Okay, so that is our project open. I'm opening with Pycharm because it's one of my favorite editors for Python. You can use any one you want. We're going to add the interpreter here because we already created the environment. So what we're going to do is we go back to the terminal and we say which Python. That's going to give us the specific Python binary that is used within the environment. That's going to contain the pointer to the environment itself. So we're going to say here, we paste the address, say OK, and that is the environment configured for the editor. I'm going to swap windows here to have the terminal closer to the editor so that we can swap between them more easily. And now what we're going to do, the first thing to create a Flask application is to create an instance of the Flask object. So we're going to say server equals Flask. And so Flask, for all intents and purposes here, represents our server. It is the entry point to the application. So that's why I'm going to call this variable server as opposed to the convention, which is calling it application. I think that's a fairly confusing name because application can mean anything really. So what we're going to do, we're going to import the Flask application object from the library. And now to show you how simple it is to create a web application with Flask, we're going to create a single root here, kind of a hello world example of Flask. It's going to be just a few lines, and it's going to serve to illustrate how you can get an application up and running with Flask with just a few lines of code. So that's going to be like this: server root hello. So this is going to be a URL hello, and that's going to be a hello function for the URL. That's our kind of view function here. We are simply going to return hello from here. It's a simple message. This is a kind of hello world application for Flask. Now, by default, roots in Flask accept get methods and also head methods, I believe. You are free to specify here which methods you want to allow in your endpoints. So this would allow you to create very granular, specific endpoints in your application for post or put or other kinds of methods. If you see, the way we declare a URL is using a decorator here. So this root decorator that comes directly from the Flask application object is what allows us to create those endpoints, and they decorate a function which is basically our view function, and that's how we get a simple endpoint up and running here. So let's run the web server and see how it works. Let's clear this here, and we say Flask app equals app server, and then Flask run reload. So the command is Flask run. That is a CLI command that comes with Flask. It is a development server. That's not a production server. You will want to use something like Unicorn or Uvicorn to run the application in production. Reload allows us to reload the application automatically whenever we change the files, so that we don't have to restart the application whenever that happens. Very convenient for development. What we need to do here also is to pass the specific pointer to the enter point in our application as the Flask app environment variable. So the way it works is we specify the module with dot notation. So imagine this is a sort of Python path. So Flask is going to sort of import this variable server from a path. Because we only have one file, there is no dot involved here. It's just the module app. Then the colon separates the module from the variable, and that tells Flask to look for a variable called server within that file. So we run this, and then we copy this URL. We're going to go to the browser here. We type the URL we declared, hello, and that's our hello world right there. So as you can see, it is the requirements are very minimal. You can get a server up and running very quickly. You can extend this however you want with any kind of complexity. You can return HTML from here already if you wanted to. And then you can deploy that to render, for example, and you have a server up and running right there. So this is one of the appealing things in Flask. It's so lightweight. It is so minimal. It is so easy to get going with it. The problem is, if you don't follow a structured approach, at some point this is going to become a liability. This flexibility can become a liability when you abuse it. So this is just to say that in bigger projects, you want to be structured, you want to be very organized with how you structure your applications. Like I said, I'm going to create a Flask APIs course over the course of this year, so I will have something to say about that. For this tutorial, we're going to keep everything within the same file, but that's not what I recommend you to do for a big project. Please bear in mind that what we're doing here is just a simple illustration. So the first thing we want to do here now is to create, because we're going to create an API, we're using Flask-smorest. So we're going to create an instance of a kind of API. So Flask-smorest gives us an API object that comes with a lot of the functionality needed to perform data validation, handle URL query and path parameters, and to generate documentation from the code. So we're going to create an instance of that. We're going to say API equals API, and that needs a parameter which is the instance of our Flask application. That comes from Flask-smorest, okay? This Flask API object. Now, we could get going with this. We can create our API directly using the API object, just like we did with server. The API object kind of extends the server, the Flask application object, works the same way, exposes decorators with which we can declare our routes. But we're not going to do it exactly that way. I want to introduce a concept here, which is blueprints. And so blueprints are collections of URL paths that belong together in a specific part of your application. It's a way, you can think of it as a way of organizing domains within your application, or URLs that somehow belong together in a specific place. This allows you to keep those URLs together, but also to add a specific configuration that is needed for those URLs. So if you have, for example, an admin interface to your application, that could go within a specific blueprint that has specific, stricter access requirements in there, so you can configure those access requirements within that blueprint. It looks like this. Because we're going to create a to-do application, we're going to create this kind of to-do blueprint. And so this blueprint is going to come from Flask-smorest also. Notice that we can import it from Flask, but that's not the one we're going to use. We're going to use it from smorest, and then we have to give it some configuration. So it's going to be a to-do blueprint with a namespace to-do, and then we're going to give it a URL prefix of to-do as well. So all the URLs we declare within this blueprint are going to have the prefix to-do, and then we're going to give it a description as well, which is to-do API. All right. So now what we have to do is we need to register the blueprint with the application object. So we're going to say API register blueprint to do. And this has to go, in this case, it's going to have to go at the bottom of the file, because we're going to create all of our routes here in the same file. So we're going to declare the routes of to do, and then we're going to register this to do blueprint. Normally, what you would do is you would implement that blueprint in a different part of your application, different file, usually a different collection of files, basically a different module or package, if it comes to that. And then you input the single blueprint, the instance of the blueprint. When you do that, when you import it, all those URLs get registered at input time. And that's how the whole collection of URLs will get registered when this code executes here. So we are nearly ready here to start creating these URLs, but we have to do something more. We have to create some configuration for Flask-smorest. We have to tell it what's the title of our API, what is the API version, which version of OpenAPI we want to use, and what are going to be the paths for our documentation in the API. So let's go ahead and create a configuration object. So we're going to say class API config. And so this follows the same approach that we would do in a Flask application to configure the server. There are different ways of doing it. One of the most popular ones is by creating these classes that contain configuration. And then we use a method of the Flask application object to load that configuration within the app. So here we're going to say API title is to do API, API version is v1. With APIs, you don't really want to have very granular versions like minor and patch. You want to have only, as far as possible, just major versions, and everything else would be a backwards compatible change in the API, so people wouldn't have to worry too much about switching from one to the other. So only major versions we would have here. And then we want to have the Open API version. Since we're doing this at the beginning of 2024, don't confuse this with OpenAI. We get this confusion now even in the API community. We're talking about OpenAPI here. I'll put a link in the description of the video to OpenAPI if you're not familiar with the concept. Basically, it's the gold standard of how to document APIs, REST APIs. So this is going to be 3.0.3, which is one of the latest versions supported by Flask-smorest. Then we're going to say OpenAPI URL prefix is going to be this. So where our OpenAPI documentation is going to be available. OpenAPI documentation usually comes in JSON or YAML, so it's going to come under this. And then we are going to have OpenAPI Swagger UI path, and that is where we're going to have this Swagger documentation for the API. That's going to be docs you're free to choose any path you want. So I'm going to call it docs here. We also have to give it a link to the assets that we want to use to decorate that UI. So we're going to say OpenAPI Swagger UI URL, and I have this available somewhere else already, so I'm going to paste it here. So that is where we can get those assets. If you want, you can also get redoc documentation generated by Flask-smorest. So you would do OpenAPI redoc path, and some people prefer to use the redoc documentation. It looks nicer, it looks more professional. Personally, I prefer the Swagger UI. It's just a lot more simple and intuitive for me, but some people really like to use redoc, so feel free to use the one you like the most, or expose both. And then OpenAPI redoc UI URL, and that is going to be the URL here. Alright, so that is our configuration object, and now we're going to load that configuration using server config from object, and that is going to be our OpenAPI config class over there. Of course, a lot of this configuration might come also from the environment, so we might have some sensitive credentials or something that we need that will come from the environment here. And as well, we can perform validation of those configuration parameters. So we are ready to get going with the API. The first thing we're going to do is, because we are doing a to-do API that allows us to create tasks and to manage those tasks, we're going to create an in-memory list of tasks. In a proper application, you would have those tasks persisted in a database, but to keep things simple here, we're going to keep it in memory. Every task is going to look like this. We're going to have an ID, which is going to be a UUID. So I got one, we can get it from here actually. There's this website, you can do UUID generator and you can get a UUID from here. I'm going to hard code that UUID so that we can have a consistent resource in the server all the time. We import this, and then we're going to say created, which is going to be date time now. And remember, datetime objects are with the now method in Python. They are going to give you the current time in your location. UTC now is going to give you a UTC timestamp, but without the time zone. So to do it properly, you have to do it this way. You say now on the UTC time zone. So we import this, we import that, and we also say completed. We're going to say false, whether the task was completed, and the task is create Flask API tutorial, which is what we're doing right now. So that's our hard-coded first item in the list, just so that we have some data in the API available for the listing endpoint or for the get specific task endpoint, so that we can already play with those endpoints and see how they are working. Now, what we're going to do now is create the routes. We're going to do them with classes. So the example I showed you before for the hello world was a function-based route. So a single function for the route, and that works very well for endpoints that only have a specific HTTP method, or endpoints that have the same functionality for multiple HTTP methods, which is uncommon anyways. It shouldn't be the case. When you want to support multiple HTTP methods under the same URL, you want to split those methods implementations in different functions. And what you can do very conveniently in Flask is to group those methods under the same class. So you can have a class that represents a specific path, and within that class you will have methods like get and post or put or delete that represent a specific HTTP methods within that route. So it looks like this. Let's say we're going to have a class which is to-do collection. So in APIs, in REST APIs, REST is a resource-oriented type of API. We distinguish between two different kinds of endpoints. We have collections and we have singletons. So collections represent a collection of items. So in those endpoints, we can retrieve a list of items, or we can add items to the collection. And then we have the singletons that represent specific items in our API. So because we have a to-do API that allows us to create and manage tasks, we're going to have a collection endpoint that represents the collection of tasks, and that is going to be declared with a decorator here. So we have our to-do blueprint here. We're going to create the routes within that blueprint. We're going to say root, and here we're going to say tasks. Okay, so this URL is going to be with the prefix to do. This is the to-do API. Within that to-do API, we're going to have a specific path to manage tasks. And that is going to be this route here. That is the collection. And to be able to make this class represent a route, we have to inherit from something called method view, which is a class in Flask that implements this functionality. It allows us to create views in our application that represent URLs as classes. All right, so we have that, and now within this class we can model our HTTP endpoints using methods. So it looks like this: def get, and we're gonna add some parameters here. For now, just a pass. So these parameters are going to allow us to specify how we want to retrieve the collection of items. We will move on to that in a moment. We have to decorate this endpoint with a response decorator, which is going to specify the status code of the response and the schema. We're going to leave the schema empty for now. We are also going to have a list of arguments which are going to represent the parameters. We're going to deal with that later. So let's comment this out for now. All right, so like I said, we're going to have an endpoint to retrieve the list of tasks, and we're going to have an endpoint to add items to the list, and that is going to be a post endpoint. The response here, because it is a post, because we are creating resources here, the status code is going to be 2.1, and it's going to have also a payload, which is something that represents a task. For now, it is going to be an empty body here. What we can do now is we can run the server and see what the Flask-smorest is going to do with this. So let's go ahead and do that. Server is already reloaded. We had it running all the time. Just to remind you what the command looks like: Flask app, the module name, colon, the application object, Flask run, that is the command, reload for watching the files for changes. So we hit enter with here, and we go to the page again here. If we hit the naked endpoint, we're gonna get nothing. It's not found because we haven't defined an empty path for the API. But if we go to the documentation endpoint, docs, we have the Swagger UI that represents our API implementation. Like I mentioned at the very beginning, also we have this JSON representation of the OpenAPI specification of our API implementation. So all the details are here, and these are the endpoints that we have defined so far under the to-do tasks URL path. So the get and the post. No details here because we haven't defined the schemas yet. That is what we're going to do now. So we have the representation of a task here. We want to have models that convey this data representation. So we're going to have a model to represent a task when we send the details to the post endpoint. At that point, we only want the user to specify the name of the task. Completed is something we're going to handle in the put endpoint. Created and ID are server-side properties, so the user doesn't have access to them. So we're going to create a model here, a Marshmallow model called create task, and this inherits from the schema Marshmallow class. And here we're going to have the only property that is allowed when we create a task, which is the task property, and that is a string. So if you're familiar with Pydantic, you know in Pydantic we define our data validation rules using type hints in Python. Marshmallow came before type hints existed, and so we use declarations like this. So we say task is a string object and it's represented like this. Now this is the payload to represent the task here. So we're gonna come here, we're gonna say todo arguments, and that is create task. That is the input data for the post endpoint. We call it arguments as in a payload here. So every input is conceived as an argument in Flask-smorest, any input to the API. Now that is how we represent the task when we create it. To update the task, we said we are going to have the completed property as well. So we're going to say update task. That is going to inherit from create task. So it's going to have the task property, but it's going to have also completed. And that is a boolean, right? So that's the model for our update endpoint, which will come in a moment. And then we're going to have the representation of the task, the full representation for the read-only endpoints. And that is going to be maybe just task. That is going to inherit from update task. So it comes with the task and the completed properties. And it's going to have also the ID, which is a UUID. And it's going to have created, which is a datetime type. All right, so what we can do now with this model here, we can say that the response has a schema, which is task, and the get endpoint also has a schema, which is task. Now we want to add some query parameters to the get endpoint here. Simple ones just to illustrate how that works in Flask-smorest. So we're gonna have a class here which is list tasks parameters, and what we're going to do is we're going to allow users to tell us how we want to sort the list of tasks. So we're going to say order by is fields. It's going to be an enumeration. We're going to specify the values in a moment. And order is another enumeration. So we're going to let users tell us which property they want to use to sort the items, whether they want to sort by task title or by created timestamp, and also whether it should be ascending or descending sorting order. We're going to create the enumerations for those values. So we're going to have sort by enum, inherits from the enumeration class in Python because it is an enumeration, and so we can sort by task or we can sort by created. And so that is the input for this declaration here, sort by enum, and we're going to have a default value here. So we specify the default value in Flask-smorest using this load default. So that is going to be sort by enum created, and that's how we ensure that this parameter always has a default value even if the user doesn't specify it. And then we're going to create the enumeration for the sorting, the direction of the order, whether it should be ascending or descending. So class sort direction enum from the enum class. So we're going to have ascending or descending. Of course, all of these parameters could be passed to a database query properly when we have a database in place. So we're going to say sort direction enum. The default is going to be sort direction, let's say ascending. So what we can do here, the arguments are going to be list task parameters, and we have to specify this is not a payload. So we're going to say that they are present in the URL query, in the query parameters. And what we're going to do here is we're going to return the list of tasks. So we need a model for that also. So this represents a task. We're going to have a collection of tasks as well. And that is going to inherit from a schema. It's a brand new model here. We're going to say tasks is fields list. It's a list of tasks. Now to declare the items within a list, we have to use a model here called nested. And within nested, we pass the specific object that is going to be nested in the list, which is task in this case. All right, so the list endpoint returns a list of tasks, actually, not a single task. The post returns a specific task because we are creating a task and we'll return the full representation of it. And we are almost ready to roll. So here we're going to return the list of tasks, and here we're going to return for now the specific task. Well, that will work. We need to add some parameters to the task. We say so task ID is UUID 4, and then task created is date time now time zone UTC, and task completed is false. And then we return, we append it to the list actually. So tasks append task, and then return the task. Alright, so the server is up and running. It's in hot reloading mode at the moment. So all the changes have been reloaded. We reload the page, and now we can try out the get endpoint, and we get an empty object. And I realize it's because we haven't done the proper object here. So if we see list tasks is an object, contains a tasks property, and that points to the array of tasks. So let's do this properly. Tasks is tasks. So if we hit this endpoint again, now we have the list of tasks, only contains one element, the one we hard coded before. We can try the post endpoint now, contains the example of the payload, only need the task property. We get the representation of that task, we get it back when it was created, the ID and the completion status. Now we can hit the get endpoint again, and we have two tasks. Now because it is in memory, every time we make a change and the server gets reloaded, we're going to lose that data. We're going to go back to one element in the list. We will have to use a database if we want to persist the data. So let's do one more thing here before we move on to the singleton endpoint. So we're going to sort the list of items based on those parameters. If we were using a proper database, we would pass those parameters directly to the database query. Because we are working with an in-memory list of items, we're going to use Python's built-in functionality to sort a list of items. So we're going to say sorted, and we're going to sort the list of tasks, and we're going to specify the sorting key. So that is going to be with a function here, a lambda function. We're going to say for every task, we're going to use task parameters order by value. Now I can do this with a specific with a hard access. I'm not doing a soft access like dictionary get value and providing a default value. I'm expecting parameters to have a value here because they have default values as we did in the models. They have the load default configuration specified here. If these parameters were fully optional, if they could be none, then you have to consider whether that value is present before you attempt to perform something with those parameters. So if this parameter could be none, then we wouldn't do any sorting. We wouldn't even consider this line of code here. We would just return the list as it is. And notice I'm accessing the value of that property. That is because they are enumerations. So remember, we are using enumerations to specify the possible values for these parameters. That is also to constrain the values that users can specify when they send requests to the API. That is not only going to give you more certainty that the API is correctly used, but also it's going to prevent things like, SQL injection attacks can be prevented this way. You don't allow users to send just any kind of input to your database. This is data that is passed directly to a SQL statement or a database statement here. So it's a great way to protect you from those attacks. There are many more things, of course. I'm going to do videos about those topics later this year, but it's just one strategy among many. And then we're going to specify if the orders should be reversed or not. And that is going to be parameters, whether it is equal to sort direction enum descending. So if it is equal to descending, we're going to start from the top, then we're going to reverse the order. If it is not equal to descending, then by default it is ascending, then we're going to do the natural ordering from smaller to greater. All right, so we can check this out in the API now, actually. So the changes are reloaded because we are running on hot reloading. We can come back to the Swagger UI here. Nothing has changed in the Swagger UI in our API specification because we haven't changed the parameters. So we can execute the same request here. We can add a few items here. We get the representation of each of them. If we hit the endpoint here again, we're going to have the list of items we created. Now we can play with, if we want to list by task, for example, then by task is by titles. It's going to do by comparing the strings in the task string here. So that is ascending. If we want to do descending, it's going to start with the higher letter in the alphabet here, so string, and then it's going to go down to the first item that is hard-coded in the list. So that is the collection endpoint. Let us move on to the singleton endpoints now. So we're going to say API root tasks. So within that collection of tasks, we are going to represent a single task. It's going to be represented by an ID, which is going to be UUID type, and then the parameter is going to be called task ID. So users are going to be able to go to the URL, say todo tasks a specific ID, and that represents a task. Now we create the class todo task is a specific task, and then the method view. We need to implement class-based roots, and I realized this is the instance of the API object, not the blueprint. We should be using the blueprint here. And so here we're going to have a get endpoint. We're going to have a put endpoint. We can perform updates on a specific task, and we're going to have a delete endpoint so that we can delete tasks as well. And because we have a task ID here in the URL path, that is going to be captured by Flask, and it's going to give us that parameter as an argument to our functions. So we have to specify the methods actually here. We have to specify that parameter in our signature. So that's going to be task ID. And then we have to decorate the endpoints with the specific responses and arguments that are needed. So we say todo response, the status code here is going to be 200, and the schema is going to be a task. That is going to be the same for the put endpoint, so we just copy that here, and then here we're going to say that the argument for updating a task is the update task model that we defined before. Now for delete, we're going to have a response with a status code of 204, which is an empty response. It's the usually common response when we delete an item from the collection. There's nothing else to return because the item is deleted. So that is a common response for those endpoints in REST APIs. Now what we do here is we have to return a specific task according to the ID we are giving here. So we're going to say for task in tasks, if task ID equals the task ID, then return the task. Otherwise, if we don't find any equivalence, abort with a 404 response, and we say task with ID not found. So abort is the Flask built-in method for returning error responses in our API. So that is the get endpoint. We're going to use a similar approach for the put, but we're going to update the task when we find the equivalent. So we say for task in tasks, if task ID equals task ID, then task completed equals, we need to have the payload here, the updated payload. So we say payload completed, and the task, the title of the task is payload task, and then return the task. Otherwise, we have the same 404 response that we had here. We're going to do the same in delete actually. So we're going to put it there for now. and this should be completed actually. Alright, so I think there are no more typos here. What we're going to do with delete is we're going to do an enumeration on the list. So we're going to use, to keep it simple, we're going to use the pop endpoint on Python lists to delete the item from the list. So we're going to say for index task in tasks, in enumerate tasks, we're going to say if task ID equals task ID, then tasks from the list pop the relevant index and return. And we return an empty response here because it is a true or false response. Otherwise, we will raise this true or false response at the end. So that is what we need really for the singleton endpoint. So let's see if that worked. We have to reload the UI to incorporate the new endpoints. And here we go, we have the singleton endpoint. So we can create a task here, for example. We create this one and we get the ID. So we can copy that. And we can bring this to the get endpoint to get a specific, the specific detail. Now we can update the task. So completion, we set it to true. There's a 500 error here because the payload has to go at the beginning here. So the order of the parameters matters here in Flask. So if we do that, go back to the UI, we will have to create the task again because in memory list, so we lose the data. But we can copy the ID of a new task here, go back to the update endpoint, put it here. Now we have the response that it's been updated. To confirm that it is actually updated, we get the details of the task here, and it is certainly updated. Now we can delete the task from this endpoint. So we put the ID. We have a true or false empty response. If we get the list of tasks, now we shouldn't find the new task we created. We only have the original hard-coded task to create the Flask API tutorial. And because we have completed the tutorial now, we're going to set this to true. And in case you're wondering why we have to send all the details of the task here, the task and completed, is because this is a put endpoint. So the semantics of put indicate that we have to replace the representation of the item in the backend based on the input here. But if you want to have a specific property updates, you would use a patch endpoint. To keep it simple, it was a put here. So create Flask API tutorial. We update this. So that is true. If we list the API here, now the task is completed. So that is how you create an API using Flask. Using the Flask-smorest framework, proper API, REST API framework for Flask. It handles data validation like you've seen here. It handles URL path and query parameters like you've seen here. It handles documentation. It has an understanding of OpenAPI and JSON schema semantics. So that is a good choice for APIs if you're using Flask. If you're going your own way, I tell you from experience, things can get very nasty very quickly. And there's always an opportunity to amend things by installing a framework like this and bringing back all the implementation to a framework like this. So I hope you like this video. Like I said, I'm planning to release more videos about Flask and Django this year. If you have a specific request of what you would like to see along these lines, please share your comments on the video. And if you like the video, I appreciate if you give it a thumbs up, leave your comments, subscribe to the channel, and hope to see you next time. Thank you.